In last lecture I was discussing about nominal stress approach. At the end of last lecture I was solved some problem based on nominal stress approach. Today I will discuss a new topics that is hot spot stress approach. In this lecture the following topics will be covered. That first of all we will discuss about introduction about hot spot approach, then I will discuss about advantage of hot spot stress approach, then I will discuss what are the steps generally we used to follow to assess the fatigue life in hot spot stress method, that I will discuss. Then I will discuss about how to calculate the hot spot stress. Then I will discuss about how to measure experimentally the structural hot spot stress, and at the end there will be references, and if time permit I will discuss about some problems. So, sometimes it is not easy to identify the correct standardized fatigue detail class for a unique geometry, because in nominal stress approach we observe that according to IIW some standard classes are available from where we used to find out what is called FAD value, which is generally used to determine the what is called fatigue life of a structure. But sometimes it is not easy to identify the correct standardized fatigue detail class for some unique geometry. So, the development of a new fatigue detail class require a large number of fatigue tests, which we know, which is a time consuming and very cost consuming process, that you can say. To avoid this disadvantage of nominal stress, that means generally nominal stress what we observe is applicable there where a standard FAD value is available, that means FAD class is available, but on the geometry is complex and geometry is not on that FAD value, then their nominal stress approach is not able to use. That is why to avoid this disadvantage of nominal stress method, local stress calculation method were proposed and developed. This generally this local stress calculation method can be grouped into two categories. One is called hot spot approach, another is called effective nose stress method or approach, that we can say. These two methods generally use instead of a nominal stress approach, where the geometry is complex in nature and where the fatigue data or FAD class is not available. There generally this hot spot approach and effective nose approach effectively we can use. Now, hot spot approach, this approach also called generally structural stress approach or geometric approach, this you should keep it in mind. This hot spot approach has been developed to enable evaluating the fatigue strength of welded structure in cases where nominal stress is hard to estimate, that I have already told you in previous 2 points, because geometric point of view or loading complexity. Due to this different complexity of the you can say geometry, as well as due to complexity of the loading, that what happens where nominal stress is not able to predict the fatigue life, there generally we can use this hot spot approach. This approach generally mainly used generally for you can say fatigue design of pressure vessel and welded tubular connection since 1960. So, this approach has been used mainly for fatigue design of pressure vessels and welded tubular connections since 1960. It is a very old process, that you can say. This method was firstly developed, when this method was developed initially, that time generally this method was used for tubular joint in offshore structure, okay. But it was generally later applied successfully in some plate welded structure also. Not only it is used for tubular connection, it is also start using in what it is called plate welded structure also. This hot spot stress method have a aim at reducing the number of further necessary fatigue experiment, that you can say, and it is also simplify the selection of what it is called correct detail class to fatigue design. So, this is also another main, you can say, positive point of hotspot approach. So, generally it is you can say reduce the further necessary fatigue experiment, as well as it is also simplify the selection of correct fatigue detail class to fatigue design. This method is generally used to investigate the close environment of the fatigue critical points, what I am telling, understand. So, where the fatigue failure is chance to happen, that critical points close environment it can predict, what I am telling, understand. Let us for a you can say for a fillet types of joint, that the critical point can be this discontinuous point, that is toe of the weld. So, in this near this toe zone, this close environment generally of this toe zone, stress distribution it can predict. The basic idea of this method is that this method generally consider what? Bending stress and membrane stress, okay, which I have discussed in last lecture itself. So, this the basic idea of this method, it is a combination, generally this hotspot stress means it include what is called membrane stress and what is called bending stress, these two part, but it is not consider what is called the non-linear stress peak, which I have already shown in last lecture, I have also discussed in details in last lecture. So, fatigue generally hotspot stress include these two component in this figure, you can say, that is called membrane stress and this bending stress component, but it is excluding this what is called non-linear stress peak, this you should keep it in mind. The effect of the NOS generally is taken into account through test result, and this NOS effect generally were used to determine the SN curve of the fatigue detail class. So, whatever the NOS effect is there, this NOS effect also generally included where it is included in SN curve. This you should keep it in mind, because SN curve is also one of the part which is used to calculate the fatigue life using hotspot approach. How it is, everything in details I will discuss in subsequent slide. What are the main advantages of hotspot approach? The advantage of hotspot approach compared to, you can say, nominal stress approach is generally the hotspot approach you can say is mainly used for more complex geometry, which is not possible to use that what it is called nominal stress approach. Nominal stress approach is not feasible, where there generally this hotspot approach method can be used. Okay. And whatever the fatigue strength value of this approach are not as strict as nominal stress approach. Okay. This is also another advantage of this hotspot approach. How it is, everything in detail in subsequent slide I will discuss. There is no recommended hotspot fatigue detail class for every type of structural details are there, and which is not required also, what I am telling, understand. There are some standard FAT class is mainly used for this hotspot approach. According to IIW and what happens Eurocode, generally nowadays presently 7 different categories of what is called FAT class are used for hotspot approach. Earlier time it was only 2 FAT class were used. Okay. What are those 7 different FAT class generally used, I will discuss later. Okay. And the main, or you can say major advantage of this hotspot approach is that here generally stress raising effect which is caused by joint member are taken into consideration. This you should keep it in mind. Let us, we are joining one what is called wave with one flange. So, what is the effect of this what is called joint members, that effect generally is considered in hotspot approach. This you should keep it in mind. And that what is called that stress raising effect also consider, and it is used for fatigue stress calculation. Another advantage is a reduced number of SN curves are needed to evaluate the fatigue life of welded details with this approach. Here also I told you nowadays only a very reduced number of only 7 different SN curve generally used for welded details with this approach. This method is mainly applicable for fatigue life assessment, you can say starting from the weld toe. So, where the fatigue failure is starting from the weld toe, in that location generally this method is mainly used. This you should keep it in mind. So, you can say hot spot approach method is used for weld toe fatigue failure. When the crack propagation or when the crack propagates from weld throat, this method is generally unsuitable for fatigue design. This is also another point you should keep it. So, this method is mainly used for fatigue failure in weld toe zone. This you should keep it in mind. What are the different steps generally we used to follow for this hot spot approach, that we should know. So, here also some steps are there to estimate the fatigue life of a welded structure. What are those steps? Generally we use 3 different steps. First step is generally we need to calculate or estimate the hot spot stress. This hot spot stress generally we estimate either by experimental method or you can say finite element analysis, or you can say it is numerical method, finite element method. Okay. FEM means finite element method. Step 2, generally calculate the FAD value. Here also FAD value is required to estimate the life. So, this FAD value we need to calculate, or you can say determine according to some standard. I have already told you there are some standard FAD value is there for this approach. What are those? This I will discuss later. Okay. And at the end, using this hot spot stress and this FAD value, we need to generally calculate the number of fatigue cycle according to the standard relationship which is generally given here. You can see that is NF, that is fatigue life equal to 2 into 10 to the power you can say 6 cycle into a factor, this is called probability factor, failure probability factor you can say, that I will discuss how it is, into FAT divided by hot spot stress to the power m. So, this relation, by using this relationship generally we can predict the what it is called fatigue life of that welded structure. So, what is FAD value, that also I will show, and how to estimate this hot spot stress sigma is, that also I will show, and what is the m value for that SN curve. Generally standard value are there, that is we usually used as m equal to 3, that you know. So, that also known. So, if we know this what it is called hot spot stress sigma is, we can easily find out what is the fatigue life of that structure. NF means number of cycle it can sustain, that you can say. So, these are the steps generally we used to follow for estimating the fatigue life of a what is called welded structure based on this hot spot approach. Now, before going to discuss about how to calculate what it is called hot spot approach, first of all we should know where generally we need to find out this hot spot approach. The point where we used to find the hot spot stress, that point is generally called fatigue critical point, or you can say that is also called hot spot points. Generally the hot spot point according to what is called Naimi and Fricke, these two researchers who recommend and he proposed this thing in IIW standard, and which is nowadays also very popularly used. So, generally this hot spot point is grouped into you can say 2 categories. One is called type A category, another one is called type B category. What is type A category and what is type B category, that we need to know, because based on this type A and type B category we will show you how to estimate what is called hot spot stress. So, generally type A, this critical point generally located on the plate surface at the well toe. Okay. So, if the well toe is at the what is called plate surface, so in that location generally type A hotspot stress we need to calculate. That means, if the toe is located at plate surface, that toe point is called type A hotspot point. And what is type B hotspot point? Type B hotspot point generally located on the plate edge at the weld end. This you should keep it in mind. What is this? Everything in details I will discuss in subsequent figures. Short weld toe, which is short weld toe? That also I will tell. Short weld toe generally it is excluding the weld leg length, that you can say. Okay. How it is, everything in details I will discuss. Like here let us consider, if you see what is weld toe, I have already shown you. Weld toe means, let us consider this is a fillet types of weld. Weld toe means the corner point of this fillet weld, this is toe, this is also toe, weld toe. Okay. Now, what is type A weld toe and what is type B weld toe point, that you need to know, that I am going to discuss. So, here you see, once the weld toe, you see this type A, here you can say this is type A, once the weld toe is located on this plate, you see this is the big plate is there. Over this big plate you can see, over this big plate you can see there are different types of wave is there. These are all wave, this is one wave, this is another wave. I have already told you, that means at the corner point of this weld face, this is called face of the weld. At the corner point of this weld face is called toe of the weld. So, if the toe is at edge of the plate, then it is called one type, that is generally called type B. If this toe is on the plate, here you can see this toe, let this is point 1, this is point 2, okay. This is point 3, this is point 4, what I am telling, understand. So, this one point you can see, this point 1 is located on weld toe and this point also located in this big plate, let this is plate 1, okay, and this is plate 2, and let this is plate 3. This you should understand very clearly. Now, you see, if this weld toe is located at any plate, it can be what it called flange or it can be web of this joint geometry. So, what is flange? You know what is flange. In case of a what is called fillet weld, this is called wave and this is generally called flange, that you know very well. Okay. In case of what is called I section, this is for T section. So, we know in case of, if the geometry is like this, so this is called wave and this is called flange. You know these things very well. So, you see, so in plate 1 you can say this is the flange plate, okay, and plate 2, plate 3, these are all wave plate, this is also plate. So, you see type A means once the toe is located at, you can say at the weld location and this weld toe is located on this plate on surface, that you can see it is located on plate on surface only, top surface. Whereas similarly you see this point 4 toe point also located on plate 1 surface. So, this is also type A, types of hotspot point, this you should keep it in mind. Similarly, point 3 which is located on a plate which is different plate, but that is called generally you can say one of the wave plate, you can say point 3. This point 3 is also called, as it is located on a plate surface this plate surface can be wave or flange, does not matter. What I am telling you is, if the toe is located on surface of that any plate, you can say that is generally called type A hot spot point. This you should keep it. So here you see point 1, 3, 4, these are all which is located on what is called plate surface toe. These are located on plate surface toe point. These are all called type A. So you can say here 1, 3, 4, these are all point is called type A, because this you need to know very clearly. What is type B? Type B, you see type B is point 2, you can see this is type B. Type B. Why? Because this B point is located at this plate edge. You see along the here, you see at the edge of this plate, that means along the thickness position, you can say. This is one point. So it is located at plate edge, not plate surface. What I am telling, understand? So type B means this point 2, this is point 2, and what happens, which is located at where at the edge of that plate, and it is also called what? It is also called short whale toe. Why it is called short whale toe? Because that is also another toe of that fillet. That is also another toe of that fillet, you can say. So you see why it is called short whale toe, because here it is neglecting, you see it is neglecting this extra length or leg length of the weld, you can say. What I am telling, understand? That is why it is generally also called short whale toe location, or you can say it is located at edge of the plate. That means that you can say. So some of the more example here I am just showing, like some of the fillet weld. So here you see this toe point, you can see figure 2, this toe point is located in this what is called flange plate, this base plate surface. That is why what happens, this is called type A types of hot spot stress. Similarly, this is a overlap types of fillet weld joint, lap types of joint. In this case also this is one toe, this is another toe, you see. So this toe, this is point 1, this is also located in this plate surface. That is why what it is called, this is generally called type A types of hot spot stress. Now for bar joint also you should know what is type A types of hot spot stress. So you see, if the toe point, this is also toe point of this is called butt welded toe point, this is another toe point, okay. So if the toe point is lying here also on the surface of this plate, and for similar thickness, this is also you can see this toe for butt, both sided butt weld, this toe also lying on the surface of the what is called this left side plate or right side plate. That is why this is called type A for similar thickness plate, type A types of what is called hot spot point. What is type B types of hot spot point? You see, this is generally type B. These both are the example of type B types of fillet butt welded joint. Like for similar types of thickness of plate, this is one plate which is butt welded with another plate. This is plate 1, plate 2, you can see. So here in this corner point, here you can see this is the corner point where you can see the stress is rising. Here you see. So this corner point, that is figure 1, you can say corner point short whale toe is one of the example of what is called type B types of hot spot stress. Now for let dissimilar types of thickness of plate, this is figure 2B, you can see this is one plate, this is another plate. So plate 1 is thicker than plate 2, you can say this is figure B. Here you can see the corner point of this dissimilar you can say toe, which is at the edge of this plate. Do you see, which is at the edge, here also it is at the edge of this plate, it is also at the edge of this plate, this toe, this toe. So, here generally you can say stress concentration is rising, here you can see the stress distribution also, this is the stress distribution, here it is showing. So, here you can see this edge of this weld is also called type B types of what is called hot spot point. So, what is hot spot point? You got the idea. In case of fillet weld, you know, on the toe is on the surface of the plate, that is generally called type A, and if the toe is on the plate edge or at the thickness location of that plate, or you can say at short weld toe, they are generally, that is called type B types of hot spot point. Okay, you got the idea what is type A and type B types of hot spot point. Now, for type A and type B, the calculation method is generally different. That related things also I will discuss in subsequent slide. So, how to calculate this hot spot stress, that we need to know. Generally, for calculating the hot spot stress, we can use experimental method, more popularly used, but experimental method is what is called time consuming phenomena, and it is also costly phenomena. That is why what happens, we can use for estimating the hot spot state by using FEA result, that means FEM analysis also we can. FEA means finite element analysis, finite element analysis. Okay. But what happens, from FEA analysis directly we cannot predict this hot spot stress, this you should keep it in mind. For predicting the hot spot stress using FEA analysis, directly we cannot measure this hot spot stress from there. For that, there is required some extrapolation techniques. What are that things in details I will discuss. So, first of all, generally by using finite element analysis FEA, you can say what we need to do, we need to predict the stress distribution from weld toe to, you can say at the surface of the weld plate or at the edge of the weld plate. Here you can see this is the stress distribution. First of all, that stress distribution we need to find out. After that, generally we need to choose either 2 point stress, that 2 points should be little bit away from the toe location of that weld joint. That 2 point, let us consider this R1 point and R2 point we can take. Once we take 2 point, for that purpose we generally use linear extrapolation approach, and sometimes if the stress distribution toward the weld toe is steep and very non-linear in nature, there generally we use, instead of 2 point we use 3 point stress, that is R3, where generally instead of linear extrapolation approach, there we use quadratic types of extrapolation approach. And in addition, a simple derivatives of hot spot stress generally also we use to predict the hot spot stress at weld toe location. This is a very simple what is called a derivation, you can say. For this purpose, we choose a point, that is 0.5 T. T is the thickness of the plate, this T is thickness of the plate. So, at a distance of 0.5 T location, we need to find out what is the stress value, this stress sigma we need to find out. With this stress, generally we need to multiply a factor 1.12. Based on this multiplication, whatever the stress value we will get, that means you can say that is called hot spot stress. HS I am writing. So, here a simple method used, that is generally called, you can say 1.12 into sigma at a location of 0.5 T. This is also very simple method also we use, which we used from the FEA result. That is why I have written in first point itself, you can see directly we cannot read the hot spot stress For that generally 3 different standard method we use, which generally widely acceptable method you can say. One is called linear extrapolation method, where 2 point stress is required there, and another is called quadratic extrapolation method. Another is a very simple method, there we generally choose a single point stress value, with this generally we multiply a factor 1.12 and we calculate the hot spot stress value. This is generally recommended by Fricke. This you should keep. This also we can use for estimating the hot spot. How it is, everything in details I will discuss now. So, from here you can observe that generally according to what is called in International Institute of Welding, in IIW standard in linear extrapolation method, generally they choose 2 point at a location of 0.4 T and 1 T. T is the thickness of the plate. This 2 point we need to choose away from the well toe location, okay. And we need to extrapolate the stress based on this 2 point. We need to calculate the what is called well toe hot spot stress. What here I am showing, you see, like this is 0.4 T and this is 1 T. So, based on this stress value, let us consider this is one stress, this is another stress. So, this stress is you can write as 1.0 T stress, and here whatever the stress we will get, this you can write as 0.4 T stress. Okay. So, in this 2 point, whatever the stress value we will get, this 2 stress by this 2 stress point, sorry, this is 0.4, this is point, you can say this is 0.4 T location stress. So, this is 0.4 T and 1 T. We using this 2 point, we need to add this 2 point by linear extrapolation. This line we need to extend up to what point? Up to the toe location of the weld. You see, this is the toe location, this is the toe location, this toe location which is lying on the surface of the plate. This up to that toe location we need to extrapolate this line, and whatever the stress we will get, this is according to IIW standard. That is IIW mean International Institute of Welding standard. Some another standard also is also favored some classification society. Okay. This approach generally you can say based on another 2 point stress value, one is 0.5 T, another is 1.5 T. So, this is 1.5 T stress. So, let us consider sigma 1.5 T, and another is 0.5 T is this point, you can see this point is sigma 0.5 T. So, by this you need to draw a line. After that, if we just extrapolate this thing, whatever the stress value we will get, that is generally give us a hot spot stress. So, from there, and after that this 0.5 T into 1.12 based on this whatever the stress value we will get. So, that gives further another hot spot stress. So, you see from this different method, what we can observe that according to IIW standard, which give us a, you can say, highest hot spot stress. So, you can say according to IIW standard, if we go for estimating the life of this structure, we will be in conservative side, because you know life of the fatigue life equal to 2 into 10 to the power 6 this FAD value divided by hot spot stress, correct. This hot spot stress generally inversely proportional to what? Number of cycle. So, if the hot spot stress value is higher side, then this number of cycle will be lower. If it is lower, then the number of cycle will be higher side. So, according to IIW standard compared to other two standard, you can see give us a more conservative result. This you should keep it in mind. Okay, that you can see from this figure. Now, how this extrapolation and other things we used to do, that I am going to just discuss one by one. So, here generally the extrapolation rule proposed by IIW recommendation, generally here you can see which I am going to show. Here one thing you should keep it in mind, that means the necessary location of extrapolation point are determined by Neyme and Fricke, which is generally further included in IIW code and standard, you can say. So, according to the research result of Neyme and Fricke generally showed that if the investigated critical point is on the surface of the plate, that means if it is type A types of critical point, then generally it is observed that the extrapolation point location should depends on thickness of the plate. That means for type A types of critical point, the extrapolation point is dependent on what? This is dependent on thickness of the plate. This you should keep it in mind. For that case, here I have shown, you see, whereas if the so another type B, here you see this is another case type B. For type B case, generally this extrapolation point depends on absolute distance, it is not dependent on thickness of the plate. This is also another point you should keep it in mind. Okay. So, that is why I have written here. However, if the critical point is checked at the plate edge, like in type A, I have already told you this 2-point stress value according to IIW standard is 0.40 and another one is 1.0 T. T is the thickness of plate. So, this is according to IIW standard. Okay. Similarly, some other or other classification society, you can say type A stress value we can calculate by using what is called 0.5 T and 1.5 T distance. So, another case type A stress we can calculate at a distance of 0.5 T and 1.5 T. This by using this 2-point stress value we can extrapolate the data up to toe point and we can calculate the fatigue water sports stress value. What I am telling, understand? So, you see for the first case you can observe that here generally required a fine mesh. This fine mesh in the sense this mesh element, generally whatever the mesh element you observe, this mesh element size always you should keep it in mind, should not exceed 0.4 T. What I am telling, understand, this is required.